Okay, good morning, everybody. Welcome to Windows on AWS. Always a little tough to have the 9 a.m. after dead mouse, but we'll soldier on. Thanks for coming this morning. I want to talk to you about Windows and how you can bring your Windows workloads to Amazon. Are we working? There we go. Okay. Perfect. So one of the misconceptions that's out there is that it's difficult or challenging to bring Windows workloads to AWS. Either that they're not supported or it's really complicated or hard to do. And what we hope to do this morning is dispel some of those myths and help you understand exactly how easy it is to do. And in fact, we have many customers that are actually operating at scale on AWS today with pretty significant Windows workloads. Whether it's Shell that does a ton of dev and test work, they've got a whole platform that runs on us. Red Lion Hotel runs reservation systems. Lionsgate Entertainment, again, pretty significant workloads. So kind of a nice smattering. And what you'll see as we get into the day today is there's really no Windows workload that you can't run effectively on AWS. And in fact, in many cases, it's much easier to set them up on AWS than it is to do it in your own data center. So one of the great things about AWS is that we give you the opportunity to have pay-as-you-go resources. So you only pay for what you use. And with license mobility, you have the ability to bring your own licenses to Amazon. So you're not necessarily having to buy licenses again that you already own. One of the key things that we offer to Windows customers is our broad scale, right? So we have 9 regions around the world. You really have the ability to set up your environment closest to where you need it. And with that infrastructure, you also have the ability to build essentially fault-tolerant applications. You can spread them across regions, across availability zones, and actually architect for the cloud, which gives you that assurance that, the reality is computer systems, data centers, are kind of designed to, at some point, they will have failures, whether it's you're on-prem or you're in the cloud. And so what we're finding and what we're trying to help customers do is actually design and build their infrastructure such that it's fault-tolerant. So when there are failures, you're architected in such a way that you can fail over into other availability zones, into other regions, and not have any disruption in service. A little slow this morning. I think the slide machine is feeling like I am. So many of you are familiar with all of the solutions that Amazon offers. Broad range of product, a broad range of product categories, everything from databases to storage and content delivery. Of course, our core compute with EC2 and all of our storage solutions with S3, EBS. And then our deployment management, which you're going to see more of today. We're going to talk to you a lot about how you can use CloudFormation to set up your Windows workloads, and then our app services. So all of this are available across our network, which gives you the ability to really leverage the tools you need in the regions that you need them. I'm going to ask Ulf Schuh to come up and do a demo. Let me introduce Ulf. Ulf is a senior product management manager on our Windows business on EC2, and really the ninja when it comes to our Windows business. So Ulf, I'm going to let you give us a quick demonstration of the console.
Great. Thank you very much, Dean. And good morning, everyone. Let me just get set up here for a second. It allows me to switch over. Oh, this is great. Fantastic. Hang on. Well, actually, let me reboot my machine here and start over again. That's a physical Windows machine. It's nothing to do with that machine running anywhere else but on this local laptop. And apparently, some of the drivers don't seem to agree here with that, with this environment. Anyhow, what I'm going to show you is actually and one of the things we want to do today is, besides making sure you understand that when it comes to your Windows-based workloads, running on AWS, it's all about your solution, whatever you want to design, building them at your scale, whatever scale you need, given the global reach and capacity that AWS provides, and doing all that backed up by the full power of AWS. You saw Gene show some of the services that we have available today. You heard throughout the show about new services that we're offering. Especially exciting are the services around workspaces where you can actually run Windows-based desktops in the AWS cloud. But today we wanted to show you from the simplest way, take you all the way through from a self-service console perspective, how you would deploy your first Windows-based instance and end up actually with some very complex solutions that you run there. And as soon as my machine is booted up again, I will actually start showing you in the self-service console the very simplest way when you walk up to AWS, how you, after you entered your credit card and your account is created, how you can actually do this. So let's do this actually here, real time, of course. I hope that my network connects back again. As soon as this little spinning wheel. Actually goes away. So I'm just waiting for network connectivity. As the console is actually a web property, we need to be able to connect to this property. And I hope this actually goes through here in just a second. Unfortunately, I don't have right now. You know what? I just don't rely on this. Let me switch over. For a later part of the demonstration, I have an iPad here, and I'll just move to that environment. And at the same time, the audio-video guys, if you could get us help on the network side, and have the networking guy come up here again and help with because the connectivity doesn't seem to exist with that device here. Could you please bring the network guy up again? Thank you. So let's do this here from, right. I happen to have a browser here. I log into my console. We got all the beautiful news about the, I use my corporate email address and my corporate account. Pardon me? Oh. We'll do that. And here you have the self-service console that you're already familiar with, and many of you are. So with regards to Windows-based Windows-based instances, launching them out of the AWS environment, it's as easy as going through the launch instance wizard. You select the type of, through the quick start, the type of operating system that you want to provide. We have a whole selection, a broad range of Windows-based SKU that you can use. So for this case, I'm choosing a Windows Server 2012 SKU that is eligible for free tiers. So you can actually, when you open up a new account, use this instance for a full year as on a T1 micro instance. So I'll select this instance type. By default, because it's eligible for free tier, this comes up as a T1 micro instance. If I want to choose and have the full range of all the instances that Gene talked about earlier that we have available for Windows-based workloads, you scroll and basically select from instances from the smallest type of instance with 1 vCPU and fairly low networking bandwidth to high-level CPUs, instance types with up to 108 ECUs and an array of SSDs attached to them. So I'm selecting right now just an M1 medium instance, configure some instance details that you have. This is part of the. Select basically where I want to launch this instance. In my case, I like to launch into an already created VPC type of environment that is there. I have the choice of using previously provisioned IAM role and an identity and access management role, which actually allows you to give other users the ability to launch instances and provide this as an individual role for them to be able to do so, but not use other services that are out there. I leave this as is. I provision a networking card to this Windows-based instance. I'll add storage. I can leave it as is here right now, or I just want to have a little bigger boot volume, and I need to run some applications out of it. So I'll provision 150 gigabyte of additional storage on this instance. I'll tag my instance the way that so that I can actually, I'm just trying in parallel here, see if I actually can connect. I'll tag my instance as test instance and configure security groups. Security groups, you probably if you've gone through several of the sessions here, are a way of firewalling your instances off from other instances. You have full control over the selections of ports that are available in the Windows environment, especially important to be able to do so. Often Windows-based instances require special port ranges, or just in other cases, individual ports you have the ability to do so. Using security groups gives you a stateful way of actually fencing things off. If you are you have another way to doing this, which is network ACLs, which is a stateful way. At that point, you actually have to be very precise on both ends of the equation, going in or going out of the subnet. And at that point, you basically review and you launch the instance, and I choose my instance type, my lab. I acknowledge that I have full access to my keys, and I launch the instance, and the launch is initiated. At the same time, then if I may actually be here in luck, it's kind of came up. Yeah, this one here. It's connecting right now. Okay, it looks like we're getting back to connectivity. Yes. All right. So at this point, I can switch back over to my Windows laptop that in the meantime has recovered. All took a little longer than we had initially planned for, but then at the same time, we didn't expect a Windows blue screen here. So now that the instance is launched, this is a little bit of a cooking show because it takes a couple of minutes for a Windows-based instance to launch. I'll basically open my RDP client, and I log into the instance. And what you will, in the end, you get is a fully functional Windows instance. There's nothing special about it. All programs are there. All features, all functionality is there, just the way you would expect it in the on-premise world. It has the network cards that you had provisioned before. In this case, this instance that I launched here, I've launched into an existing Active Directory environment, so I've logged in with my Active Directory credentials. In this case, if you would launch this instance standalone, we have a very secure way of actually doing this on a unique key pair that gets provisioned to you and to you only, so only you have access to those type of instances. And as I said, this is in the end, this is your instance that you have there. It's full Windows, fully functional, fully working. Takes a couple of minutes to do so. From any device, we have the same AWS console is available from an iPhone. I just did it here from a web browser and an iPad. Great that I had it right now here handy, so we could bridge the time. But that's that part of the demonstration.
So that's just kind of simple Windows console. I want to talk a little bit about some of the challenges. So Windows is pretty simple, but many folks then say, well, what else can I do with Windows workloads? SharePoint is a great example where customers, this is hundreds of steps, maybe 1,000 steps and 100 clicks to provision one, but it's actually pretty straightforward to do on AWS. And then one of the things that's super important I talked about earlier is how do you actually create the right physical separation in your network? How do you configure your hardware to provide the right secure solution? And what I'd like to do now is ask Ulf to come back up and talk about how you actually can configure this easily on AWS.
Great. Yeah, thank you, Gene. You made a great point there. That's very, very important. Those of you in the audience, may I just see a quick show of hands? Who is deploying today like SharePoint in an on-premise world? Quite a few of you, right? Anyone has deployed SharePoint in a cloud-based environment? Okay. So if I may just go really quickly back to the, oops, let's see if this actually takes, nope, one too far. If I take this thing, so we put this slide up there, not as an eye chart for you to try to read it and to understand every part of it, right? This is just there to make a point. As Gene said, there are literally hundreds of steps involved if you want to deploy a full enterprise SharePoint farm anywhere, on-premise and or in the cloud. And from just simply deploying multiple Active Directories to have a high availability solution, one Active Directory domain controller and global catalog, at least in each subnet. If you want to have a high available database behind the scenes, backing up your SharePoint environment, you may choose to have automatic failover in the database. So you deploy a server cluster and a highly available database with SQL Always On in SharePoint 2013. You have a multitude, depending on your application, a multitude of application servers serving specific roles, being Office Web Services, web app services, or being indexing service, fast search. And then, obviously, if you have an application, maybe a public-facing website that is for 5 days of the week, hardly used, but because you service a special type of event during the weekend, then all of a sudden you go from a handful of users during the week to hundreds of thousands of users throughout the weekend, as some partners and customers have deployed actually in real-world environment for some specific sports that happen on the weekend, and they get served in this type of environment. So you have you have truly these challenges of setups that take normally in the real world. What would you say? Is it a 3-month project to set up an enterprise SharePoint farm? Who agrees? 3 months project? 6 months project? 2 weeks project? What would you think, what would you say if I tell you you can deploy this in basically 2.5 hours, the infrastructure on AWS? Fully automated, front to end, to the point that you truly only have to do the configuration piece of the SharePoint in itself. SharePoint at that point is already installed, licensed, installed, and you just go in and configure your farm, or don't have to deal with any of the other things. And as Gene said before, and this is just software, right? And in this case, you actually deal with additional hardware pieces. If this is an example out of the Exchange world, where you deal with mailbox servers that need, or that you want to have on multiple networks because you want to have logical separation between mail networking and replication network, and want to have this run in the most efficient way. So the programmable infrastructure that we have in place in AWS allows you to do that end to end. Doesn't matter if it's just software, hardware provisioning in form of network cards, storage volumes, all that is very possible. Let me just see. So the question is, how do we do that? And for the Windows world, you can do it in AWS using the tools you already use today, the tools you are most familiar with. Who here is the Windows users as a Visual Studio user? PowerShell, right? So you can do all these things using the tools you're familiar with. The AWS tool set for Visual Studio and for PowerShell are powerful tools that enable you to deploy these solutions end-to-end in a fully automated fashion. So let me give you a quick overview over the tools for CloudFormation and for PowerShell. And just before I switch over here, as I had to reboot the machine, I have to bring up my Visual Studio environment. Earlier during this event on Tuesday, and I see a couple here in the audience that worked with me on Tuesday through a full-day boot camp, where we actually worked through all the pieces of a full enterprise data center, setting it up in AWS in a fully automated fashion. So we went from deploying a VPC over multiple Active Directories in 2 data centers, in 2 availability zones, through deploying a Windows Server failover cluster in SQL Always On, and last but not least, a small Exchange infrastructure. But this here is just a sample, and that was something we worked on in this class, a simple sample that the students wrote to actually deploy just the networking infrastructure. So you have parameters if you want to give users the ability to actually configure their subnetting infrastructure so it meets the corporate environment if they choose so. And there are a couple of resources that you deploy. In this case, it's just simply a VPC, a couple of subnets, and an internet gateway. The integration into the tool set is seamless. So all you do at that point, you say deploy to AWS CloudFormation, give it a name. I say I want to deploy this in my Oregon region. Hit next. Here you see the parameters that I've written as code in, so a user can actually look at this and modify them. I hit next, review, I hit finish, and the infrastructure deploys. Now, some of you have probably gone through some of the CloudFormation talks. They explain in all the details what is going on behind the scenes, as CloudFormation is a very, very powerful service that takes a lot of the sequencing and the thinking and makes it transparent to you what you have to actually deploy. So you only care about the pieces that you want to deploy, and CloudFormation figures out in which order this has to happen. So as you can see now, the whole stack starts deploying, and in about 50 seconds to a minute, you have a full virtual private cloud network, in this case with 12 subnets and an internet gateway provisioned to it. If I would go in and add additional routes and for a private route to secure all the instances inside the subnet and a route for public egress out of the environment, it wouldn't take much longer. So the infrastructure provisioning for an enterprise Windows-based environment is lightning fast. And while this is finishing up here, you see create complete. So we started at 9:27:21, 9:28:31, so just a little over a minute, and the whole environment was provisioned. And that's just CloudFormation. A very, very powerful service available to you to deploy these complex solutions. Now, let's contrast and compare this with PowerShell. I'm opening up PowerShell ISE, the integrated scripting environment here. I'm getting an error message. Okay, did not close. Great, it has all my stuff already right there. So again, this is one of the exercises that the students worked on on Tuesday during the lab. It's actually exactly the same thing as I have provisioned before with CloudFormation. The only difference here is, for those of you who are familiar with writing code, the difference here is CloudFormation is a declarative language. So you have no language constructs, you have no conditionals, you have no loopings. You have a very constrained set of functions where you can maybe do a little bit of lookup tables, but that's basically it. In PowerShell, as an imperative language, you have the full gamut of dynamic conditionals, loop constructs that you can use. And I've used this here just to write in a very short way in basically 74 lines with a little bit of commenting in it. So let's call it like 65 lines of code. A fully automated way to deploy exactly the same thing that I've done in CloudFormation before. And let me just run this for you here. And just let me make this a little bigger here so you can see the whole thing deploying. All right. So in about a couple of seconds, the PowerShell script executes, and this was about 4 seconds. The same thing is deployed. So CloudFormation with additional value that lies in the workflow engine behind the scenes that actually sequences things the right way. However, if you want if you want to have the full power and the speed of a command line interface, in this case, the PowerShell command line interface, and the dynamic nature of this, that you can actually take parameters from all sides, react to input from users out of other applications, or even connect and stitch multiple of those CloudFormation templates together. You can do that in PowerShell super fast. This was about 3 seconds. Contrast this to a little over a minute in CloudFormation. So very, very powerful way of doing so. Let's keep going here and do a couple of more of those demos. Do you like this? Is this interesting to you to see and valuable? Great. Then let's do some other things. Let's have some fun this morning. And I promise I don't show any more code. So no worries about that. The next thing is Windows Server failover clustering and SQL always on, high availability, automatic failover. It's an area that many of you need to have in place and need to be able to run in the AWS cloud in order to provide highly available, automated failover within multiple data centers to truly eliminate single points of failures for your valuable data. All that at high performance with the lowest possible failover time. So I want to give you a quick demonstration of how actually Windows Server failover clustering running on Windows Server 2012 and SQL Server always on availability groups works in AWS. And for that, we have written a little demo code that actually goes against a SQL test database. All this is very simple. It's just for demonstration purposes, so it's no optimized code here for a high transaction or anything, but it's there and designed to make a point. So I'll bring up here 2 instances in parallel. Let me just switch over. Otherwise, I'm talking and you don't see what I'm talking about. To your right, you see a very simple application. Again, you see this application is written to the standards that you need to write to in order to talk to an always-on availability group in SQL Server 2012. It's written to the SQL listener, which then automatically takes care of understanding which nodes it's currently talking to. So in this case, right now, the primary replica is Windows Server failover cluster node number 2, right there in the middle. It says that all nodes are actually up and running. And so I will start this little application here right now. And you will see very slowly, like a row counter, because that's all this application does. We call it a blaster app. It blasts the database with row inserts. I've let it run yesterday quite a little bit, so a lot of rows are already inserted. And at the same time, I'm going to be the mean administrator on the other side. And I'll actually do this here in a controlled fashion. You could actually just terminate the instance. But in this case, I'll just simply go into the failover wizard. I say I want to now. Right now, the primary replica is Windows Server failover cluster node 2. I want to fail over to cluster node 1. So when I hit finish here, what you will see on the right-hand side, for a very short moment, the row inserts will stop and then restart again. So behind the scenes right now, cluster node does a couple of things. It switched over the DNS to the current active node, and the row inserts continue. So this was not even 6 seconds. Probably something your user won't even notice if they are running SharePoint, for example, or a web application So fully automated, the full power of Windows Server failover clustering for broad regional distribution of your databases. So you can imagine to run an automated cluster for automated failover within one region between two availability zones, two data centers, if you want to think about it this way. And then have actually, if your customers, if you as a company are on the East Coast and you have customers on the West Coast, you can actually have read replicas anywhere because these read replicas would be asynchronous and don't affect the database performance overall. But that's nothing special. There's nothing special. It's just the way you would expect it to work in an on-premise world. The only nice thing is, when do you have the choice to actually have multiple data centers built for you? Right? We have done this for you, so you can just take advantage of it and you use it. Great. Let me stop here and actually introduce you to Kuldeep from Dell Software, formerly known as Quest Software. And he is going to talk with us about another very interesting technology that actually shows you how you can utilize your existing SharePoint on-premise investments, and if you want to start slowly working in a hybrid environment and dip your feet into this cloud space and take advantage of some of the services that are available there. So he will, this one. Okay. So Kuldeep will show about storage maximizer for SharePoint, and I'll let him take over from here, and I'll switch you over to your.
Okay, thank you. Great. So I'll be talking about storage maximizer for SharePoint, which is one of the offer that help you offload your blob content that resides in content databases. So when you have a lot of blobs stored in your content databases, the performance as far as the users are concerned becomes pretty sluggish. So instead of storing these blobs, which are broken down into smaller files in SQL Server, you can offload these files into the cloud, like an S3 bucket, or you can do it on a local disk. So what we do is, since Microsoft provides a couple of APIs that allows us to externalize this content, so we can use both EBS and RBS APIs. So essentially what we'll do is we'll take the content that you're uploading into your content databases when you're interfacing with SharePoint. Instead of putting it into the SQL Server database, we will externalize it to a location that is, you can define. You can put it on-prem or you can put it on the cloud. So the provider that we have provided is the storage maximizer for SharePoint, and that's something that I'll be showing. So as far as the solution is concerned, it's fairly simple to install. It's fairly easy to configure. Oops. So you can externalize the content, as I was mentioning, to your cloud, or you can put it on a local disk. The interesting thing that we do is while you're externalizing your content, we can encrypt it, we can compress it, so it has a smaller footprint. So when it comes to backup and restoring, it has a much faster time to do both of those activities. It integrates with the central administration console, so you don't need to learn a new technology. So, and I'll show you in the demo, of course. It has a rules-based engine, which essentially allows you to externalize content based on certain rules that we've built based on the size of the file, the age of the file, and the type of the content that you're uploading into SharePoint. And of course, we have a reporting dashboard that allows you to see how much of the content is inside the SQL Server database and how much of it is outside the content database. So when you are talking about externalizing content, we've seen that the time to recall this content, it speeds up by at least 25%, because when you have externalized the content, it's a single file. So it's a much more efficient way of storing content instead of putting it into the SQL Server database. So when you recall a document from SQL Server, it has to put all those files together and retrieve it to the end user. So because we exercise it, it shows it from that location. And from upload perspective also, it is 30 to 50% much faster because instead of hitting the content database first when you're uploading the content, we evaluate the rule, and based on that rule, if it satisfies, it goes into the content database. Otherwise, it goes into your external location. From migration perspective, if you're moving from an older SharePoint platform to a newer platform, it increases the speed from that perspective. The biggest, of course, saving is the reduction of the SQL Server footprint. So from storage perspective, you can reduce that cost significantly. So let me switch to the demo here really quickly. So what I'll show you is, so there's a simple document library in a SharePoint 2013 site. So I've enabled the content to get externalized to an S3 bucket, and I used the TNT drive, which is the Windows client for S3, to mount that bucket onto my Windows system here. So essentially, when I upload content into my library, and the context could be like your farm, or it could be a site collection, it will evaluate that and it'll externalize that. So just wanted to quickly show you. So I have a bucket here. I've externalized some content already. So essentially, if I go to my central administration console, in my application management, you'll see it gets installed as a feature. So you can see the storage maximizer link. So from the dashboard perspective, as I was saying, it tells you from your web application perspective how much of the content is in the SQL Server database, how much of it is externalized. So as you can see, there are 6 documents that have been externalized, and these documents have been externalized to the S3 bucket, and most of the other ones are within the SQL Server database itself. And of course, shows it in a nice chart as far as what percentage of it is in SQL and what is outside. But more importantly is the storage definition here, which is a very simple way of configuring. So essentially, you provide a name to your externalization. We primarily work with the file system, but because I was able to mount my S3 drive to my local disk, I was able to specify a UNC path to that bucket. And this is where you define the scope. So when it comes to externalizing content, you can say that, hey, when people are uploading content into my farm or a web application or a site collection, you can quickly tie in what the scope is for your externalization. And in my case, I've just taken a simple document library. So, and of course, it allows you to select based on what tab you're on. And this is where we build the rules. So I've basically said that, hey, anytime there is a file that's greater than a certain size, externalize it, don't put it in the content database. So you can define that rule here. And of course, you could enhance that. So if you're looking at some media files that you don't want to put in SQL Server, instead you want to externalize it, you can define the type of the file you want to externalize. You can activate that filter. And of course, you can define multiple file types. You could say, hey, your video files, your PowerPoint slides, you can externalize. You can also, so if you have a lot of content that's stored in SQL Server that is aging, and you don't want to have an expensive storage to keep that there, you can, again, move it based on the age. So we'll look at the age of the document, and based on the filter criteria that you've specified here, it'll move it out into that external location. We also have the ability to externalize content based on some of the metadata that you have in your list or library. So based on, so you can, of course, build that criteria really quickly here. So I'm just going to keep it simple. So all I'm going to do is, hey, anytime there's a document that's of size greater than 10 kilobytes, just externalize it. And of course, if you are looking to make sure that you have a local device where you're externalizing your content, we can encrypt the content so that if somebody has access to that location, they'll not be able to read the content. So you can create an encryption key here, which will generate automatically. So if I go back to my document library here and I upload, so the nice thing is only the blob is externalized. The stub that connects to that blob, all of the metadata around the document, that's stored within SharePoint itself. So I'll upload a document here really quickly. We'll just do one of the documents here. So as I was mentioning, the nice thing is, so there is a working storage area where we will check. So if you've noticed, we create a hash, and we, instead of keeping the actual file name, we take the GUID of the document, and we keep that name so that people can't retrieve it. So it gets evaluated in a working space, and then once it meets the rule, it'll go and put it into the cloud. Or if it does not meet the rule, it'll put it into the content database. So it'll take, there's a timer job that runs behind the scenes. It runs every minute, I think. So soon you'll see that this document will move from this pending queue, which is like a processing area for our solution, and it'll upload it into the bucket here shortly. So while it's still processing, so you could tie in the RBS provider to different content databases. So there's a configuration utility that I'm not going to share, but you could. So it's gone from here. And as I said, I have locally mounted it here. So if I refresh, it added one file here just now. It's still updating it. But more importantly, if I go here, it was able to externalize my content into my S3 bucket. But when I go to SharePoint, the user will not know whether that document has been externalized to the cloud or to a local disk. It just gets served up to the end user. So it's created an entry here. You should see an entry for today. So it just got done here. I think it's this one. But for the end user doesn't know where the document is. So when I go up here and say, hey, I want to be able to read the content of this document, SharePoint automatically will go find out where that blob is, and it'll serve it up, and it'll show in the UI, and open. So it doesn't have to go back and look through the different blobs within SQL Server itself to rebuild that file. So it's more faster. And this is the PDF that we uploaded, which is being served up from the S3 bucket that we had uploaded it to. So that's what I had. Okay. And of course, if you need more information, you can go to our website and you can get more information about our solutions. Thank you.
Great. Thank you very much, Kuldeep.
Thank you.
So this was run, Kuldeep, this was run right now. The scenario we have chosen for this demonstration was like an on-premise SharePoint environment, externalizing the content blobs into S3 on AWS. Of course, the same thing could run where SharePoint in the entire farm itself
Correct.
would be in AWS. At that point, the paths would be even much faster to just push it out into the service.
That's correct.
Great, thank you so much. I think we are pretty much at the end, but I wanted to quickly check my email and see if there's any last-minute items that I have. It's not showing right now. Let's see. Okay. Let's see if it shows my. Okay. This is great. Awesome. There we go. So I just wanted to quickly make sure we didn't miss anything. So let me look at my mail here. This is right now our client running against Exchange in running in AWS. Just see, I got this.
Hello, Ulf. This is Steve calling to check in on you and see if you are ready for the AWS demo today. Thanks.
Great. So my colleague Steve in Seattle, we have been working on a demo environment. Actually, in the end, it's a customer deployment for running fully integrated Exchange and Link out of AWS. So let me see. So it looks like he's ready. Let me see how this is working. Let's see if Steve is around. I can IM with him. Should be online. His presence information is percolated. Okay, Steve is there. Let's see. So let's see if he is available for a quick conversation. So it's ringing on the other side. And there's Steve. Hi, Steve. How are you?
Hello. Good, Ulf. How are you?
Great here. We have a room full of people actually having listened to our presentation this morning, and we wanted to end with this wonderful scenario that actually, oops, the iPad sometimes disconnects here, with this wonderful scenario of a fully integrated Exchange and link infrastructure with presence, with voicemail integration into Exchange, with video and audio, all running out of AWS. And as you can see, I think the video quality you all are seeing here on the screen is quite impressive.
Hello, everyone.
All right, Steve, thank you so much. Go back to your work. We didn't want to bug you too much, but we wanted to share this with the audience here so you see how this is working, at what kind of quality the network environment provides for us. So any of our customers at any scale, from small to medium business to any enterprise environment, can run these very complex and complete solutions in the AWS cloud. Thank you very much, Steve.
Thank you, Ulf.
All right. So, and I think, Gene, shall we close it out? I think we are at about time. So, yeah. Let's see. That's what we've just seen. Last point. Most of the things you have seen here today is not just us telling us about it. You can actually go out there. We launched earlier this week the test drive program, and with several of the partners already providing real-world test drives. Second Watch provides a developer workstation, F5 a load balancing solution, InfoReliant apparatus provide Exchange, high availability Exchange solution. These are things where you, on a single click within 30 minutes in your environment, you can actually put your hands on these type of workloads and experience them firsthand. And it's very exciting. Go try it out right now. Check it out. It runs for, some run a couple of minutes, some run a couple of hours, but you can see firsthand how it behaves and how it works. We have many of these deployment scenarios published, so if you want to read about it, front to center, we published documentation and guides and templating solution that you can run in your environment and set these type of environments up from SharePoint to Exchange to Windows Server failover clustering. And with that, I think we're at the end, and we would be here for a couple more minutes to answer any questions that you may have. Thank you very much.